Good morning, all. Today we will see about digestion and absorption of lipids. I will start with this simple case where a 36-year-old male patient complains of repeated attacks of pain abdomen associated with nausea, vomiting, loss of weight, and excretion of greasy stool. This we have to note. And he complains that which the stool cannot be flushed away easily. So that's the major complaints any layperson will tell. On examination of stool, it showed an excretion of 12 grams of fat per day. Ultrasound abdomen showed inflammation of pancreas. With the history, the examination of stool and ultrasound, he was diagnosed to be having steatorrhea secondary to pancreatitis. End of this session, we should be able to define what is the steatorrhea, why pancreatitis will lead to excretion of unsplit fat, causes for split and unsplit fat excretion, and also the role of pancreatic enzymes, bile salts in digestion and absorption of lipids, and what are the dietary advice we should give when a patient is suffering from pancreatitis with regard to lipids. So these are the questions we will be answering in this session. So these are the specific learning objectives. You should be able to list various dietary lipids, various enzymes and hormones which are involved in lipid digestion, role of bile salts in lipid digestion and also in absorption, and finally the advantages of having emulsification process and formation of micellar structures. Then we will see what are the end products of lipid digestion, how actually absorption and transport happens. Then we will be answering what is steatorrhea and causes for steatorrhea with its basis. So let us start with this a nice breakfast images. So you can see this is dosa, idli, vada, egg, omelette. So these are the various diets we consume in our day-to-day life. Even though there is not a visible fat, but you should understand the food items, whatever we consume, along with the other nutrients, we consume lipids also. So the dietary lipids, the sources can be animal or plant origin. And on an average, a normal adult will consume 20 to 30 grams per day. And the major dietary lipids we consume are triacylglycerol, cholesterol, and phospholipids. Apart from that, we consume other lipids also. So the enzymes which are available in our body for the major dietary lipids are lipases, which acts on triacylglycerol, cholesterol esterases, which acts on cholesterol ester, and phospholipase, specifically phospholipase A2, which acts on phospholipids. So we will see what are the major sites or organs involved in lipid digestion. First being mouth. Digestion starts from mouth. Then up to 30% happens in stomach. And finally we have small intestine where complete digestion and absorption also starts here. So we will see the process of digestion in mouth. Because of short stay of food in the mouth, there is only minimal digestion. Very important enzyme in the mouth is lingual lipase, secreted by Ebner's gland, a salivary gland. The optimum pH for its activity is 2.5 to 5. Because of this, you can see that the activity of this enzyme continues in stomach also, as the stomach pH is also very low. Special feature of this lingual lipase is it acts on the triacylglycerol, which are esterified with short chain and medium chain fatty acids. So this is what we all should understand. The lingual lipase will act on TAG with only short chain and medium chain fatty acids. So the sources like milk, butter, ghee, coconut oil, they are all rich in TAG with short chain and medium chain fatty acids. So it hydrolyzes the ester bond present at the first carbon and third carbon. It will not act on second position. This enzyme is very active in infants. That's why for infants it is good to give the sources of TAG from these dietary components so that digestion becomes easy. Moving on to the process in stomach. In stomach, there is gastric lipase produced by chief cells. Again, the optimum pH is around 5.4. Its action is almost similar to lingual lipase, and 30% of digestion of TAG happens in stomach. The complete or the major digestion happens in small intestine. Very important juice is secreted into the small intestine, that is duodenum, by the pancreas, that is pancreatic juice, which is rich in a majority of the digestive enzymes, and also it has the bicarbonate. Bicarbonate is very much required to neutralize the acid chyme which enters from stomach to small intestine, because all these enzymes are active in alkaline pH. The important enzymes present in pancreatic juice is pancreatic lipase along with colipase. Then we have phospholipase A2, cholesterol esterase. The prerequisite for the digestion in small intestine is emulsification of fat should happen, and there should be an alkaline pH mainly to neutralize the acid chyme, and the bile salts and bile acids secreted from liver. That is gallbladder, it is stored and it is secreted into duodenum whenever there is food particles entering the small intestine. So these are the prerequisites for the complete or final digestion of lipids. So we will see what is this emulsification. So emulsification is nothing but where lipids are dispersed into smaller droplets which will increase the surface area and reduce the surface tension. So when a large fat globule is broken down into smaller particles, there is increased surface area so that enzymes can act easily. Apart from that, bile salts will help in detergent action in causing emulsification, and the mechanical mixing will happen by peristalsis, and the important compound lipid, that phospholipids, will help in solubilization of these particles. Action of pancreatic lipase and colipase. Already we have understood that lipases are the ones which will act on triacylglycerol. So triacylglycerol will have a glycerol backbone esterified with three fatty acids at first position, second and C3 position. Now we will understand how exactly this lipase with colipase will digest triacylglycerols. So that's the triacylglycerol molecule. Once colipase binds to this triacylglycerol, so the red dot I have shown is a colipase. Once it binds there, it will allow the action of pancreatic lipase. So that's why without colipase, pancreatic lipase is not much active. Now this pancreatic lipase will sequentially remove the fatty acid particularly present at C1 and C3. It will not release or hydrolyze fatty acid present at second position. So sequential release of fatty acids. Now the remaining structure is called as 2-MAG, that is 2-monoacylglycerol. So it's a monoacyl glycerol. Where is it present? At the second position. Otherwise known as beta MAG. So we can assume that 2 is beta. Alpha is 1, beta is 2. And majority of the end products of pancreatic lipase action will be 2-MAG. So 75% of lipid products, digestive products will be 2-MAG. Now if you want to remove this 2, then either you have to shift it to 1 or 3. So we have one more enzyme, that is isomerase, which will transfer or shift the fatty acid from second position to first position. So converting 2-MAG to 1-MAG. Now the pancreatic lipase can act on this, remove the fatty acids. So then we can have glycerol and free fatty acid. But do remember, more than 75% of products will be in the form of 2-MAG. That's why it is also called as MAG pathway. Coming to the action of cholesterol esterase enzyme, this will act on cholesterol ester, hydrolyzes it into cholesterol and free fatty acids. Phospholipases, specifically phospholipase A2, will act on phospholipid, removes the free fatty acid, and the remaining structure is called as lysophospholipid. These phospholipases, we have different phospholipases, phospholipase A1, A2, B, C, D. We have variety, but important one is phospholipase A2, which will remove the phospholipid, the fat present in the phospholipid at second position. So the remaining structure with one fatty acid, a phosphate group and a nitrogenase base to the glycerol backbone. Now this structure is called as lysophospholipid. This is very important. This lysophospholipid can solubilize everything. So it is a detergent action. So it solubilizes. Very much important in snake bite. So venoms are rich in phospholipase A2. So it solubilizes the lipid bilayers. As I said, there are other phospholipases. So we have phospholipase A1, which will remove the fatty acid esterified at first position. Then we have D. D is the one which will remove the nitrogen base. Phospholipase C will act at the third position, removing the phosphate and the nitrogen base. So these are the different phospholipases and their point of action, but the majority is the phospholipase A2, and this phospholipase A2 is they actually synthesized in proenzyme form, which is activated by trypsin. Bile salts are also required for its activity. It is inhibited by cortisol. So the glucocorticoids will inhibit this phospholipase A2. So at the end of the final digestion, the digestive product, if you look at, more than 75% will be 2-MAG or beta-MAG. Up to 10 to 15% we will have 1-MAG. Then free fatty acids will be there. Free fatty acids, if it is a short chain and medium chain fatty acid, they enter the portal circulation. Only long chain fatty acids, they have to be formed into chylomicron and micellar formation, then they will be absorbed. Glycerol also will enter the portal circulation directly. Cholesterol phospholipids will be absorbed into the intestinal mucosal cells. So that's about the digestion of lipids.